Thank you for coming. This topic is a bit different than everything else, at least what I heard here today, because it's not that focused on a particular technology, and it's not maybe, absolutely Java oriented. It's a bit broader topic, and but it still is a purely that touches development, so it's related to your daily work. Extreme programming practices, I wonder why you have come here. Probably because extreme programming, people are curious about what it really is. You probably have heard ideas like test-string development, or pair programming, or collective code ownership, or some other practices of extreme programming. I will not probably be giving a very detailed introduction to extreme programming, but the goal of this talk is to try to convince you that it makes sense to use, if you're not able to use extreme programming as a software development method at your company for many reasons. Maybe it makes sense, or we try to convince you that it makes sense to use at least parts of it, some practices of it, for development. My name is Paul Lipinski. I come from Poland. I've been working as a software developer for, I'm not that old, so I can say a long time. As for my age, around 15 years. I own lead the company Pragmatists for roughly 4 years, a bit more. And what's different about this company than most companies that I know is that when I was starting the company, my idea was to really try to do it the right way, the way we're reading in the books, the way you can hear, Uncle Bob talking about software. If you're reading books about agile methods, let's try to do something like this and let's see if it works. I had a previous experience working as an agile coach for different companies, and so I had the background for managing the process, and I knew what agile software development is. I also had some background in practices, but I had never before used it as a whole with a kind of decision that yes, let's try to work this way. And the company is currently 4 years old. It doesn't look like we're going to shut off the business. So apparently it just works. What I will be talking about here is partially the needed theory, and partially what we at Pragmatists have experienced working this way. So one of the elements that when you're looking for a job, currently before preparing for this talk, I've looked at job offers, not in the Ukraine but in Poland, but I guess they're probably somehow similar, is that currently every company claims to be agile. When I was starting developing software, not many companies were saying they're using any methodology or any method. Most companies, if they were claiming they're using some method, it was a formal method. So these were big companies using RUP, for example. And smaller companies didn't say they're using some method of developing software. Nobody was even asking that kind of question. It was pretty normal, we make some analysis, we design or not, then we develop, then there is a testing phase, production, next project, right? That was what, where I grew up as a developer. And now you're looking at job offers, and we're doing SCRUM, we're doing agile. At best, if you want to join us, have some experience in working in SCRUM, something like this, right? So currently nearly every company claims to be agile. A few years ago, before I started my own company, I was working for Nokia Siemens Networks, which was a joint venture of Nokia and Siemens. And it has inherited a part of culture from Nokia, which was for doing agile projects. So Nokia was really trying to be agile this good few years ago. And agile consultants who were working with Nokia created something that's called a Nokia test. Nokia test was supposed for teams at Nokia to be able to verify how agile they are. So it was created by, as far as I remember, Bas Voddy and Craig Larman and I think Jeff Sutherland. So one of the important names in agile environment. And this is the first part of the test. Iterations time boxed and shorter than 4 weeks. So basically, if your iterations are 4 weeks or longer, it meant this is not agile. You're not going in the right direction. Newly created features tested and working at the end of each iteration. And that basically, it doesn't only mean that we have iterations and we try to do something during the iterations. It means each iteration ends with a package. It ends with finished features. You know, sometimes this will not be all the features that were planned for this iteration, but in general, every iteration, it finishes with everything that was possible to be done during the period of time. And it's coded, it's tested, it's working, it's ready to be delivered. Then iteration must start before its specification is complete. So this means, you know, you are not, if you're preparing in very detail what you're going to be working on, if you think you have answers to all the questions, this is not the right direction as well. We should be starting iteration with the assumption in our head we don't know everything. We will be clarifying things. This is what in Agile Manifesto, one of the principles is the teams or developers, and don't even affecting teams, on a daily basis talk with the customer. So, you know, there's nothing to talk about if you know everything, right? So, so this was the first part, and this is not, they weren't saying this is agile. They were saying, this is, if you're doing this, this is just iterative software development. But there's a second part saying that was for Scrum, because Nokia was pushing towards Scrum, and the rest was, you know who the product owner is. So everybody at the team knows who the person is, and if they have questions, they know who to ask. There is a product backlog prioritized by business value, which basically means you have very clear objectives of what you're supposed to deliver, right? And they are by business value, which basically means we're delivering what customers really need. Then the product backlog has estimates created by the team. So if the deadline is being given you by an architect, by the project manager, and you are supposed to keep that deadline, this is not Scrum at all, right? Or the deadline and the scope, obviously. I mean, the estimates need to be done by the team, because the only way for the team to commit, to say, yes, we are going to do it, is that they are able to give the estimates. The team maintains burn down charts and knows their velocity, so the team is reflecting on how they're doing and trying to look into the process, and they're measuring and verifying, having the assumption that if we don't measure something, we really don't know it. How can we say we will deliver either the process nor our speed, right? And there are no project managers disrupting the work of the team, so the team can self-organize. The team can decide how they want to work. How many of you work at companies that fulfill this test, that can say, we're really Scrum? Okay, there's one person. Congratulations. Yes, because I mean, this is not that often. This is not that often. I personally think if somebody has a chance to work at such a company, this is an experience and this is a great deal of learning. This is also an environment in which you can grow as a software developer. So, you know, I think everybody should at least have the experience working in such environment, and then you can decide, let's go to some corporation. Okay, but where has it all started? So let's get back to the beginning. Year 1970, Mr. Winston Royce is presenting on a conference about software development a paper, a document, in which on the second page and the first page, you know, there's a big title and a big name, so there's not the first page. On the second page, there is this drawing. Who doesn't know the drawing? You know, it's clear, right? Everybody knows it. So, and there's a text below it, implementation steps to develop a large computer program for delivery to a customer. So if you read this and you look at this, you think this is what he encourages you to do. The truth is that, you know, if you really read the document and not only focus on the first picture in it, he actually said that this approach that he's describing is risky and invites failure. And then he goes on saying why this is risky and what should be done instead. And at the end of the paper, he came up with something like this. But nobody knows that this is the real method that he was proposing. People who were reading the paper, in the 70s, most of the software was not web startups. I know it's hard to believe it now. It wasn't iOS applications. Most of the software was going to army in public sector. So if a standard has been accepted by Department of Defense of the United States, it meant this is the way everybody should be doing. And unfortunately, people from Department of Defense participated in that conference and have seen the first picture, and this is how the waterfall model has, came into as a now traditional way of developing software. Because everybody, if they wanted to do software, they had to do it this way. So that's kind of beginning. What are the results of it? The idea of doing all the analysis and all the design at the beginning came from a few reasons. One of the reasons is, there was a guy called Barry Boehm who in, I think, 1980, he coined this, he wrote this sentence, cost of change grows exponentially with time. So he said, if we need to change something during analyzing the problem, it's much cheaper to do it than once the software is done, right? So the later we are with making decisions, the worse for us. So basically this means we need to take all the decisions at the very beginning to have the cost of change minimized. The second reason was in 70s, and probably nobody here can remember that period. Some of you maybe have read about it in books. Computer programs were not on flash drives and in the internet and on Bitbucket or GitHub. If you wrote a program, it was being physically punched on cards, right? So you had that high stack of cards, and you were going with that stack of cards. So first, this is an investment in Brazilian forests, rainforests, right? Then you had to take it and you had to go with it to the computer room. The computer room was probably as big as this one with one kind of computer inside, and it was put into the computer, and then was the phase of, compilation and processing, pre-processing, post-processing, and then the program was running and you could execute your tests on it. Test-driven development was not possible because it's very hard to test drive code that you write in paper, right? So again, the feedback cycles. How could you learn that something is wrong in your code? You had to wait a few days. There was a queue of developers who wanted to deploy their software, and there was only one computer. And everybody wanted to test their software to verify. So I've got a friend who's currently over 70, and he was a software developer in late 60s, beginning of 70s, and he was saying that it was normal to wait 4 or 5 days to be able to get the cards put into the computer, right? So they were spending all this time on verifying. They had to spend a lot of time verifying if the code is, perfect to every dot, right? How much does it cost now to verify if the program compiles in Java? You need to properly distinguish red color from black color in your IDE. That's all. On the other hand, I don't know how people with colorblind are coding. Is there anybody colorblind here?
It's red and green.
Underscores.
That's good. Okay, that's a different topic. Let's not touch this one. This is not a medical conference. Okay, so the other thing is bugs which are found early are much easier to fix than bugs which are found late, right? If we create a solution, we spend time on other things and we need to come back because a bug has been found during testing phase, which is, I don't know, 3-6 months after we've developed it. What are the reasons it's hard to fix a bug? Probably you have forgotten what you've written, but I don't think this is the core reason. The core reason is after you've written a piece of code, there was a lot of other pieces of code that were created afterwards, and they started to be dependent on your code, and they started to be dependent sometimes even on the current behavior, which is buggy, right? So fixing a bug may result in 20 bugs popping up in all the different places in your application, right? So that was the initial thinking. So then computers got a little faster and people started thinking, you know, everything is fine if we're writing according to military specification. This is not going to change for sure during the implementation. In the worst case, something will be added. But in 80s, software started to be used for other things, for business, and you know, games were so also for entertainment. And people started to think, you know, we had to do something with this cost, and we need to be able to react to changing situations in the market, to changing situations in, you know, this is not military, so some requirements are not, you know, that formally specified. So let's do something about flattening that curve. Let's be able to let's see if we can do something to be able to introduce changes later, or even, as we currently say, let's even be able to encourage our customers to introduce changes, because this is the only way to really exist in a highly demanding market, which is highly competitive. So one idea with which agile people who are promoting agile techniques and agile methods have come up with was they've seen that if we reduce the feedback cycle about the quality of what we're doing, about the bugs, the feedback cycle between the development and customers, we can kind of flatten that curve. It will not, you know, it will not be just flat. It will be slowly growing. Obviously, as the amount of code grows, it is harder and harder to work with the code, but it doesn't need to be exponential. And so this is how the Agile Manifesto appeared, and these people got together, and one of these methods was Scrum, obviously. And Scrum is currently the most popular Agile method. Why is it the most popular? If you look at Scrum, there is absolutely nothing about software development. There's even nothing about software. There's also nothing about development. It's just a framework for doing any project. So if you're doing Scrum, it's great, but it doesn't tell you how you should be coding. It doesn't give you any directions. It only creates a cycles of feedback from which you can learn how to improve, right? So first, Scrum is very simple. So it's very easy to say we are doing Scrum if we have daily meetings with developers and we say we have iterations because once every 2 weeks we're showing something to the customer. Many companies already call this Scrum. Scrum also kind of allowed pretty long iterations. You can see this says 2 to 4 weeks. My experience working with different teams and doing different projects is 3 weeks is a total maximum. I cannot imagine planning for 4 weeks, doing a detailed planning for 4 weeks and knowing what we're going to deliver in 4 weeks. Moreover, if you're working in a dynamic environment where people come up with ideas, which is just a creative, good environment, healthy environment, it's impossible to really plan for 4 weeks because so many things will change. They will not hold anymore. So, but it's from the corporate point of view of many corporations, it's much easier because it nearly fits what they currently have, right? Or they think it's easy to bend what they currently have to Scrum. On the other hand, this is a well-defined process. You take the book for Scrum, it gives you clear method of what to do if you want to do Scrum, and because you have a clear, well-defined process, you've got certification. So there's currently even 2 organizations that certify. One wasn't enough. Now there are 2 organizations that certify people, and once you're certified, this is a kind of machine that starts working, and this is a huge marketing management, a marketing idea, right? So this is a way I think Scrum is so popular. The problem with Scrum is many people think this is just the same, right? We're saying we're doing Scrum, we're saying we're doing agile. And from my perspective as a developer is that Scrum does not solve any of the problems of quality. It solves a lot of problems in terms of how to deal with customers. It creates some new problems. At least it gives guidelines. But it doesn't say anything about software development. And this is what we're doing. So XP is Extreme Programming was a method which was saying not only how to manage your project, but also what to do to produce something that is of very high quality. The goal of Extreme Programming was creating high quality software, right? And not only from the perspective of the software itself, but also from the perspective of code itself, but also from the perspective of communication with the customer and doing exactly what customer wants. But because Scrum has become so popular and a lot of money was connected with Scrum, because of certifications, people, the whole idea of coaching, most of people from the XP community, they have just moved and became certified Scrum trainers because this is where they could start making money from what they were, doing daily, right? But now I think it's a good moment to start coming back to Extreme Programming, to look at what we've forgot. I haven't seen a book on Extreme Programming for a long time. Probably the last one was written 15 years ago or 12 years ago. Probably 12. So let's try to see what's there and what can we take from it. Kent Beck calls Extreme Programming a discipline of software development. It means that it's just like sport. In sport, there are certain things you can do, and there are certain things you cannot do. Like my son is a water polo player, and water polo has really very strange rules. For example, that would be perfectly okay if the guy in front had a ball. So if the guy has a ball, you can nearly kill him. Maybe not kill, but you can press him under the water, just do anything to get the ball from him, right? So apparently he had the ball, I guess. He's just lost it. So now this is illegal. So there are things you cannot do, there are some things you must do to say, if you're throwing a ball with your hand and the ball is of that size, you cannot say that this is football, right? So there are certain rules. So I want to give you a few rules for extreme programming given by Kent Beck, and they are pretty strange. So the first one is you must write tests before code. This is test-driven development rule, right? If you want to if you want to create something of high quality, this is the way to do it. Tests before code. Then you must program in pairs. This is pair programming practice. Then you must integrate frequently. This is continuous integration practice. You must be rested. So that was called a 40 hours week practice, which basically means people should not work more than 8 hours a day. And obviously, if you have a deadline on this Friday, you probably can spend a few hours more, but then you should have a right to a proper rest. On the other hand, when people from Western European countries hear about 40 hours a week, They are terrified because, for example, in France they work 35 hours a week normally, right? So that must be terrifying for them. Half a day more. Okay, you must communicate with the customer daily. We don't believe that a planning at the beginning iteration will answer all your questions. A daily communication is what's absolutely needed. You must follow customers' priorities. Developers very often have, it's very easy for us to start project or to choose tasks which are more interesting for us than the tasks which are currently important. So extreme programming says, you know, it's great that you're interested in something, but the business drives the development. You must leave software clean and simple by the end of the day. So each day is being finished with something that is compiled and that is building, and you have a package. You know, potentially it's not finished, obviously. You cannot maybe deliver it because it's got some functions that have been, you know, begun but and not finished. But at the end of the day, we've got something that's well refactored, may not be functionally complete, but this is just a good piece of software, right? Something that builds and is ready. You must adapt the process and practices to your environment. And I've even read, I couldn't then find where was the quote from, but I remember reading one of the XP books an idea, I think it was Kent Beck's, that if you're doing extreme programming the same way, you have the same process for more than a few iterations, I don't remember the exact number he was giving, this is not extreme programming anymore. The adaptation of the process is built into the process. So if you don't adapt it, you've stopped doing it even though you're repeating it. So this is not a repeatable process, this is an adaptive process. Okay, then why is it called extreme? Many people think that it's called extreme because programming in pairs seems kind of extreme. Here, why should two people be doing the same thing that one person can do, right? Or why should we be testing something that doesn't exist yet, right? So this is not true. This is not the reason why it was called extreme programming. There are two main reasons. The first reasoning behind it is if something is hard, let's do it more often. This sounds a bit extreme, right? But this is the way we learn to do things which are hard. So, for example, designing is software. It is hard, right? Design, currently it's probably not that often anymore. I remember a few years ago, the career of a developer was you were junior developer, then you were developer, then you were designer / developer. So this is something certainly complex. I'm giving a lot of trainings and I see that improper design is something that people have most problems with. Or any design that is well thought is a problem that people have problems with. Is something people have problems with. So if something is hard, we're doing it more often. And design is an element of everyday work in extreme programming. And I will show it to you in a second. Testing is good, right? So let's do testing all the time. Let's do testing be an element of the way we develop software. If the software is readable and simple to understand, this is good, right? So we're refactoring software all the time. Refactoring as one of the driving forces of proper design in extreme programming. If feedback is good, and it is good, right, to have feedback, let's have a lot of feedback. So we have pair programming in which we have feedback from the other person every few seconds. We have test-driven development in which we have information from our unit tests. Are we going the right direction or not? This is an information. This is feedback, right? We've got continuous integration where I know every hour, every some period, we get information about all the tests in the system. Is it working? Is it not working? If we have static code analysis in our continuous integration environment, we'll also be learning about the statistical part of what we're developing, right? We have what's the coverage, what are the measures of quality, like, I don't know, McCabe's complexity or CRAP. So these are things we may learn very often. Then we've got daily meetings, where we learn also from others how the project, how healthy the project is. Then we have iterations in extreme programming are always 1 week. There is no other choice. They're always 1 week, because this is also, from my perspective, this is a pretty natural. This is how I have a weekend during which I don't work. So I would like to start something at Monday and finish something on Friday. This is kind of natural. So we have the iteration of 1 week, and beginning, end of iteration, presentation to the customer of the progress. We're getting information from the customer. So there's a lot of feedback loops. We've got retrospectives it's a kind of feedback loop from other members of the team, how they see our behaviors and how they see our performance as a team. So we've got a lot of feedback loops, and we've got a lot of information to learn from. I will not be going through all the practices of extreme programming. This is basically how they look like. I will just pick the ones that are related to us as developers the most. And the ones that I think are maybe not easiest, but are doable to implement in your teams without going to your project manager, software development director, whomever, and saying, we need to change everything in our company, right? So let's see which elements you can work on in your teams if you only find a common agreement in the team. Who knows what this is, other than the rocket? This is a Ariane 5, a project of European Space Agency, and the project costed took 10 years of development, of preparing for it, and costed roughly, I don't know precisely, but probably rough 5 billion euro. I think that's a good number, right? So that's a cost. There's a lot of software in that kind of thing. That was 2005. A lot of software in that kind of thing. You know what this is? Yeah. It is the same rocket, just probably 20 seconds later. So the situation was, I don't know the details, but the situation was there was a cast from a floating number to an integer, and somebody thought that 32 bytes should be enough, and apparently they were not. And that was the code that was controlling the position of the rocket. So a pretty, I think, crucial element. And it was working in a previous version. In Ariane 4, the same code was working, but Ariane 4 had engines that were not as powerful as this one. So if you have more powerful engines, everything behaves a little bit differently, and the counter has been exceeded, and 5 billion euro and 10 years of development have just evaporated. No, a lot of trash probably is left. Okay, so you can say, yeah, but we're not really coding mission-critical systems. We're coding web shops, we're coding startups, we're coding maybe banking systems if we're really, doing something with challenges. But this will never cost 5 billion euro, so, but you will get something like this, probably, right? I know this is not as fun as blowing up a rocket, but on the other hand, this is a screenshot from Atlassian Jira or Confluence in the cloud, so this is probably something that a few thousand people have seen. So I think this is also pretty embarrassing, isn't it? That's embarrassing to that your software does something like this. So we would like not to have it. What can we do to not have such situations? We cannot eliminate absolutely possibility of this happening. So let's try to minimize it. And test-driven development is one of the ways to minimize the probability of such situations. So test-driven development is a technique of developing software based on repeating a very short cycle. And by very short, I mean really minutes. The whole cycle usually takes maybe takes, I don't know, 20 minutes to up to half an hour, and sometimes less, sometimes just a few minutes. What it means is, in the red phase, we are coding the test. And the test is a very bad name, because test implies there is something to be verified. And this is not a verification. In future, this will be verification. But when you're writing it, this is not a verification. This is a definition of what you plan to do. So you need to have a very good understanding of what you want to achieve. Then once you have the test, you're making the test pass. So you're creating an implementation. But the point is to create as simple implementation as possible, to make it, to get from the red state to the green state to the state of something that just works as fast as possible. So we're not trying to find the best architecture, the best design for the given solution. We want to have something that just works. The goal, why we want to have it? We want to have it because we want to be sure that we are able to implement it in a reasonable time. We want to be sure that the size of a task is so small that it is doable in a reasonable time, in a short time. And that we can learn that, yes, we are in this test, this specification was good, and we can implement something that fulfills this specification, right? And then once we have something working, we can make it nice, right? So we're getting to the refactoring phase, and we're working on making it nice, making it readable, I don't know, fast, making it, fulfilling the requirements of quality that you have. There's another reason why we want to do it. The other reason is that when you're writing, yes?
May I ask a question?
Sure.
So can we
get back? I will try to do it. Yeah.
So okay, could you describe how exactly you do this?
I will get to it in a second. We'll give an example. The second reason is there is something that's called acceptable quality. And this is something that customers really have. Customers say, we want software, but we want it not to suck. We want good software. So we will accept that it's being done when it doesn't have more than, 10 major bugs, 50 minor bugs, something like this, right? This is the moment when we can say, okay, not perfect, but we can accept it. So this is the red line. And then when you're developing software in a typical way, without testing and development, and without often refactoring, and you're just adding functionality after functionality, what you're getting is the quality drops down. You've got bugs that you know about, but you don't have time fixing because there's a pressure. Maybe they will not be found, maybe I will fix them later. But bugs are pretty, this is, not everybody is leaving bugs, okay? But everybody is leaving shit in the code. Just everybody's leaving shit in the code. If you don't have a dedicated time, every time you write something, you will have bad day. It will be 10 to 5 and you want to leave because, 5:30 you're going with your girl/boyfriend to movies, and you will just leave it like this. Next day you'll take something else, right? And you will be leaving shit in the code. So slowly the quality drops down, but the number of features, it goes up. We've got a lot of features. We don't know what the quality is because we are not measuring it in any specific way. We can guess. There is this very famous measure of code quality via code reviews, the number of what the fuck per minute. It's probably one of the ones that make sense. A good heuristics. So at some point we are at a level that it's absolutely not deployable, but nobody will be deploying because there is a testing phase, right? So testing phase and fixing bugs, and we are landing at a level that customer says, not perfect, but okay. And then we are going to have the second release, right? So we're adding new features, adding new features, adding new features, adding new features. Guess where this line will be? Somewhere here, probably. I'm not saying this is 25%, it's just any number. Just, I didn't know how to do it without escape. And initially, initially it's 100% because 0 lines of code, 0 bugs, right? So this is the only real number here. Okay, and so what happens in the second release is it's even harder to get to the acceptable quality. And the customer said, yeah, but the minor bugs were not that important. We can accept if there's 65 of them, right? And slowly we get to the moment that the software needs to be rewritten, right? So we don't want to do. There's one other thing. If we're not doing real iterations in terms of being able to deploy every package that comes out of an iteration, my time is finishing. That is leading every iteration, we are not able to deliver every iteration, right? If it's not tested, if it's not fully working and tested, each package after each iteration, we don't know how much time will it take to deploy it. So what we want to do, so actually this is never in acceptable quality because we're sometimes we even don't know if we are able to create a package. So what we want to get is something like this. We work on the quality all the time. Every day we work on the quality. We work on the design. We have refactoring as a part of our every cycle. Every few minutes we're doing refactoring, little here and little there, to continuously keep the quality. I'm not saying 100%, but high enough to give our customers the possibility to deploy anytime. If they come to us and say, this Friday we'd like to have the package in production, I'm saying, why are you telling this to me? And just take yourself a package from Jenkins, right? Yeah, this is what we would like to have, right? Or even better, maybe we can even get to such high level of quality that we have continuous deployment. Every commit that passes all the tests goes directly to production and nobody's even verifying it, right? That would be perfect. So, this is one of a good metaphors for for test-driven development. If that lady, imagine if she doesn't have that line and she is not Tom Cruise in Mission Impossible, what is the chance that she will not get to the top? I don't know. No, I think the chances are pretty high. Maybe she's very good, but many people, they would never learn climbing up. They would die very quickly, right? The death ratio would be very high for people if they didn't have the ropes and the nails. So how they do it? I don't climb myself, but I can imagine they do it like this. They come to the rock, and the first thing they're doing is nailing the rope, right? I probably already at this level would like to have it well nailed because you can see I have a little wound here because I've just recently I was inline skating in a city and had a little accident, and that was that high and it really hurt. So from that height I think it's even worse. So they're nailing here and looking where can we go further, which is the good way, right? Where can I easily put my leg, hand, whatever. So they're test, implementation, right? Test, implementation. And then, oh shit, I cannot move from here. Refactoring, right? This is the way they're doing this. So, we first specify the contract, red face, specification of the contract. Let's say we want to create a clock. We don't have any code, which basically means we can create anything. We're looking from outside, from usage, not from implementation. So what we can do is we can create whatever we want. We can create the code in such a way that we will be satisfied when using this code. We want to create the test, design the API of what we will be developing in such a way that will be be just comfortable for us. So what we're doing, we're thinking, I know all the design patterns in the world, so which one fits, right? Or something. How would I like it? How would I like to use that code? What do I want to do? So this is the design and thinking part. And I come up with something. And I get a feedback, is the code, does it look good? If I'm working in a pair with somebody, you very quickly will learn if it's not understandable. He will say, I don't understand this. If you work together longer, it will be probably much less soft. We get information about testability. We learn, what is the setup part of the test. How big is it? Do we need to mock 30 different objects, or is it short, right? This is testability. So we can learn a lot of things. Then we get to the implementation phase, in which we, as quickly as possible, want to get to the right behavior. And when we've designed the test, we've already done most of things, of thinking. We already know exactly what we want to have. So unless this is a really tricky algorithm that we are developing, this should be pretty easy. And if the test is really unit, it tests one simple situation, that should not be a big deal. On the other hand, there's a lot of things that we can learn while checking what's happening after having implemented the feature. So we learn at some point that it's working. We learned that we haven't broken anything else because all the tests are running still, right? They are not passing. They are passing. They're not failing. If the implementation takes little time, I'm also learning about, is it the right size? And this is, then I'm working on how the code should look like. So I'm refactoring. This is the moment that I'm spending time on the design. I'm working on the quality. And I'm getting information on the quality. So now, how to start doing it? If you want to start with libraries, there is some knowledge to it, but this is not the core. The core is the mindset. For people I was giving before this conference, I was giving a two-day training in test-driven development, and I think the people who participated, they could see that that's the point. It's not the libraries 2 or 3 that we're using. It's bending your mind, changing completely. We're having really trivial examples that you as developers could just hack probably 15 minutes, and people are spending 2 hours on such thing because it's a completely new way of thinking. So how to start doing it? You just need to start. You just need to spend some amount of time. I don't know how much it is. My experience, it's something around 2 weeks of really doing this all the time to get to the moment that you're really thinking from the perspective of the contract, from the perspective of specification, and not from the perspective, so from the perspective of what and not from the perspective of how. And then how to make it stick in your team. So it's best if you can do it with the whole team. If you can do it in pairs, that's even better, because then you will have the discipline of not skipping the phases, of not forgetting tests and not forgetting to refactor. It's good to have somebody else look at your code, and my also experiences in test-driven development to spend time with your code and help you with it. In getting test-driven development as a practice of the whole team. The second thing is refactoring. I know how I'm going to do it in half a minute. Okay. Refactoring. Martin Fowler said any fool can write code that computer can understand. Good programmers write code that humans can understand. And this is what refactoring is all about. It's about making code readable, maintainable. And this is what I wrote some, 12 years ago. And I found this code recently, and I have no bloody idea what it does. That's pretty simple. It probably wasn't refactoring either. Okay, so there is a nice library for people who are not doing refactoring. If somebody in your team is not doing refactoring, just get this library. You can annotate your code as well. So what refactoring is modification of the code without changing its semantics. Refactoring doesn't mean a phase of 2 months, 2 weeks of changing your code. It's really, changes that are easy to implement and modify only how the code looks like. Don't modify what the code really does. And in order to be able to safely refactor, you need to have a good set of tests. So how to start doing good refactoring, be able to refactor in a productive way? Tests. Learning, design patterns, object-oriented design, these things, solid rules. So, and this is something extremely important. Learn all the shortcuts that you have in your IDEs. This is very important because that increases the speed of your development a lot and of refactoring. How to make it stick? I think from my perspective, people who know their IDEs very well, they do refactoring. This is because IDEs, if you don't have IDEs which support you, I've been talking with people from Ruby community, for example, and what I've heard from one guy was, in Ruby we're not refactoring that much because the language doesn't need it. And I said, but there is an inherent complexity that is being changed and you need a refactor because that's a different solution. I don't know. And I think it just comes from the lack of tools, right? So I think that's the main thing that makes the refactoring stick in a team. Okay, next, you know what this is? This is pair programming. In pair programming, the idea is to switch pairs. It's the first guy codes first, the second guy is trying to understand what's happening in the broader scale. And the first one is focusing on on the bits, the low scale. And then they're switching position, switching keyboard, switching. And the second one is responsible for what's being created, and the second one is the part of trying to fit it in the broader scope. Okay. So people who started doing, and one of the nicest thing about pair programming is that you can very easily match it with test-driven development. Test is being written by the first guy, implementation by the second guy, refactoring by the first guy, and then change. First guy implementation, second guy implementation, first guy. Yes, tests, And this is called JEEConf. This is the way we started working at our company, and this is the main way we're working all the time. It just gives a very good dynamics of working. This is also a funny quote for a guy who converted from the traditional way of developing software to pair programming, and he said, the biggest challenge for me personally was essentially mourning for the death of programmer man. Programmer man is how I think of myself when I've got my headphones in, speed metal blaring in my ears, and I'm coding like a motherfucker. My fingers can't keep up with my brain. I'm in the zone. Who does not know this situation? I know it perfectly. I was spending nights coding like this, right? For most of my career, this image is what I've considered to be the zenith. When I've come home and was in programmer man mode most of the day, I feel like I've had a good day. Pair programming undeniably killed programmer man. This was a topic adjustment since I've considered that mode to be my favorite for so long. Now I see, however, that programmer man was, without me knowing, a technical dead man. So coding without somebody else looking at what you're doing encourages you to make shortcuts, to not refactor, to skip little tests here and little tests there. Having somebody, this is why coding is not only about number of lines per minute. Okay? This is a funny quote from Rob Jeffries, one of the XP founders. Don't be afraid of pair programming. You're not as good as you think, but you're not as bad as you fear. And I think that's the main point with people acquiring pair programming. They're afraid that somebody will see their code. We're so afraid that somebody will see and command that we're lousy developers. And I remember before working at that kind of teams, when we had code reviews, that was a judgment day. There was the team lead who was just sitting in front of everybody else, pointing to your errors, and you were trying to defend yourself. Yeah, but you're doing something like this as well. You know, this is not productive way of doing. So the best thing is, you know, this culture of we're continuously learning. That's the main point. Okay, you need to have a comfortable position. In our company, we've got 2 keyboards, 2 monitors, 2 mice for each station because you need space. It's good to switch pairs to be able to, you know, learn how other people are coding. Can you imagine a poet or a writer that has never read any other person's book and he's going to write a book? This will not be a Nobel Prize. Okay? So they make it stick comfortable positions. You can start with, you know, whatever you have in your company, but at some point you need to invest in the second keyboard. I know this is maybe very hard, right? Especially at corporations. How can you justify this, the purchase? Initially you need to force everybody to pair, otherwise this will not stick. First few weeks everybody must just force them to pair, and then you can loosen up. Okay, we're finishing. Collective code ownership. This is what we know, right, from many projects. So somebody's responsible for a component. It's very good for the quality because nobody will spoil it, and then the person goes to vacation. And we cannot modify anything. And when will this bug be fixed? Oh, in 3 weeks, right? So instead, we want collective code ownership. Collective code ownership means everybody in the team can work on any piece of software, on any piece of code, and there's not a single element that you cannot touch. There is no such thing as my code, your code. All the code is team's code. So anybody in the team can do it. I'm finishing, yeah. So how to start doing it? Initially, just start with one module. And try, even though it was somebody's module, try to share it. Try to tell everybody you can do it. And have people who wrote it take part in you know, cooperating with the person who's doing changes. What we often do is, because even in a team that tries to keep this practice, you know, we're focusing on things we like, we prefer, we feel good at. So sometimes we're actively asking for tasks that we don't feel comfortable with. To be, you know, to learn more about the software that we have, that we're doing, and to just learn more about developing. So yeah, a few more things, but without automated tests, this is also, you know, you cannot responsibly introduce everybody being able to change any piece of code. You can do it responsibly without automated tests. And this is mainly about culture in the team. So this is not something that, you know, there are strict rules. This is a matter of culture. Okay, Jenkins, continuous integration. Continuous integration, Jenkins everybody knows, right? So very quick, I need this one. There's a lot of tools, a lot of servers, so you can pick any that you like. But continuous integration is much more of a culture than a tool. This is a culture of making sure you're committing always something that works. So you're not pissing everybody off with not working commits. You're not blocking others from deploying their changes. So never leave the office if the build is broken. Always clean code at the end of the day. Don't comment out failing tests. If you've changed something and it resulted in continuous integrations, saying something's not working, don't comment it out and try to fix it as soon as possible. But time box fixing, so that you can, if it takes too much time, don't block others. Revert and then start again. So be responsible for what you're doing. How to make continuous integration stick? Usually it's a matter of the time it takes to build the system. If you optimize the process, if it takes little time, it's much easier to make it stick and make it valuable. Many companies just have continuous integration and they even don't know what to do with it. because they don't have tests. So yes, it builds something. You can really have a lot of value from continuous integration. So you can get a fancy info radiator that will be telling you, build broken, build good. Have notifications that are really bugging you, then you will pay attention not to commit bad code. Have different types of tests and have different jobs for different types of tests, so that you have different, depending on type of test. You have for unit tests, you get very quick feedback cycle, but for integration, end-to-end tests, you can afford a few hours maybe sometimes, right, to test everything. So that's basically it. And pair programming is something that, as you can see, kind of joins all of the practices. So extreme programming, that's basically this, right? This is a diversity of what you're doing at work, effectiveness in quality being the most important driver of why we want to do it. Thanks.